These are the three main things where most people seem to fail in the exam. Hi everyone, I'm an structural engineer working in the UK with over a decade of experience now. And I passed my IStructE exam a few years ago. And what I'll be doing today is I'm going to be choosing one of the exams in the past papers website in the IStructE and going through the exam. In this case, it's going to be the exam from February 2023, and I'm going to start with the section 1A. The plan is to go through each section of the exam and then explaining what am I doing and why am I doing it, and giving you the key points where normally people fail in the exam. So for this exam, the exam in February 2023, I chose a question 4, which was a faculty building. The first thing I did was had a look at the plan view and the section, and then once you have a look at the plan, start reading the client requirements. Then the first thing I do is to write the key points. So what's the key points that I'm taking from in the client's requirements, the limitations, the restrictions, and the difficulties in this building. So in this case, the first one is, you can see there was a large roof cantilever. It was about 8 meters. Then there's a change in the building outline or orientation. So from the first to the fourth level is the same, and then at the top level there's a hole that just is twisted like 90 degrees. Now they give you the limitations of how many columns you can use and what the spacing they must have, or the minimum spacing. So there were 12 columns in the external perimeter that needed to be at least 12 meters apart between the level 1 and level 4. And the level 1 and the highest level, both of them needed to be open spaces. And there were only 2 internal columns that were allowed between level 2 and level 3. Or 2 columns internally that were allowed in level 2 and level 3. Now, so far, we basically been repeating in year and when we write it, all the things that the client requirements are saying, and we haven't really added something of our own. Now this part is key when they tell you about the 2 internal columns, is because they're basically telling you that there will be 2 options or 2 main options to consider. The first one is if you try to design the whole building as if it's just open spaces in the ground floor and throughout the height of the building, or maybe you can just create a transfer structure. So then you will have all your external columns, and internally between level 2 and level 3 you can have the transfer structure that will possibly help the roof, because of the top level it has that kind of like twisted or different shape. Now the next thing to do is, once you explain how you plan to overcome the difficulties and kind of like having a column arrangement, is to define the construction zones or the allowed structure zones, as I wrote in here. That's basically the area between the ceiling and the floor of the level above that you can put your structure. They will give you limitations. In this case, for example, for the level 1, they say that the clear height had to be 5.6 meters, and then you needed to have a 0.4 meter no structure free zone that was for services, ceiling, and other stuff. Up above that is where you could have your structure. We didn't know yet what was the actual height for the allowed construction zone, and it's because we haven't yet reached the part where it tells you the maximum height of the building. So what I started doing was I started just drawing what was the clear height for each level that was required. So you can see it's 5.6 meters. Then I added in red the 0.4 meters, which is the free or structure free zone for services and others. And then the above the 0.4 meters in blue is the area which doesn't have a dimension yet. We're still to find out where our structure is going to be. I did the same for each level, so you find what your construction zone or your construction depth is for each level. So the level above was 4.6 meters the clear height, and you had 0.4 meters again they needed for services, and that was the same for level 2 and for level 3. When you went to the top level, level 4, it was slightly different, and the reason is because the height was different. Rather than being 4.6 like the others, it was 6.2 meters that they needed of clear height. They still needed the 0.4 meters of no structure zone, and above that they required the, well, is where I showed the height or the possible construction zone that we could have. But you can see there kind of like a guidance on, okay, here's the area where I can put my structure, here's where I definitely don't have to have any structure. Now these sketches, you should try to make it to scale. I try to make sure each square represented about 2 meters, but the pen that I was using was just too thick and doesn't allow me to do sketches, good quality sketches. So for next video, make sure that I have a better pencil. In the client's requirements, it says that the height to the eaves was 30 meters, but it also allowed the height to the maximum part of the cladding of the roof to be 32 meters. And they told you that the roof could be of any shape. So what they're trying to say in there is just, hey guys, you can be here as creative as you want. Now, when it comes to the drawing in section 2 on the exam, you don't want to really go very creative. You want to keep it basic to make it easier for you. So we probably go with a rectangular section, but you could just be creative for the option that you're not going to go for. Now, in the client's requirements, it tells you that because the maximum height to the eaves is 30 meters, then I did the deduction of the total 30 meters minus all the areas that we already had as clear heights or structure-free zones, and that gave me a total of 7.4 meters for the overall height or depth that I had for in the construction zones. In here is where the span to depth ratios come very handy in section 1, and it's because, well, you need to try to find out what's the actual depth that you're going to need for each level. So I worked out what was the maximum span that I had depending on the location of the service course, and I could see that the maximum span seemed to be 8 meters on the cantilevers and 10 meters internally. I took the cantilever because 8 meters cantilever with its effective length is basically about 16 to 15 meters. So I took 15 meters just to get a round number and divided it by the span to depth ratio that is recommended for primary trusses. I took this recommendation from the Structural Engineer Pocketbook. It's a great book and it has a lot of information. So normally for primary trusses, the span to depth ratio is between L10 and L15, so 10 times the depth or 15 times its depth. That's the span that is normally recommended. So I took the 15 meters and then divided by 10. That gave me a depth of about 1.5 meters, which is what I was planning to use for the depth of the primary truss on the roof. What I noticed was the difference, 7.4 minus 1.5 was 5.9, so I reduced it to 1.4 to get 6 meters of remaining construction zone that I could use in the other levels. So basically the top roof level had a construction zone of 1.4 meters, so 1.4 at the eaves, but it could be increased plus 2 meters in the middle location of the roof. Construction zones and the other levels was left to about 2 meters for each level. Finally, one part, very important part before starting creating your two alternatives, is define the ground conditions. So it's how you're going to support your foundations and your ground slab. So in this case you got topsoil, then loose soil, then medium dense sand, and then sand. Now the medium dense sand and the dense sand are probably what you want to put your foundations on, especially the dense sand, which has an N40. Is very good, this value, and is only about 3 meters below ground. So that means that you could use shallow foundations, and it's probably the option that I was going to go for. And the explanation, it was just first, well, you got suitable ground at that level, and your groundwater was 3 meters below the dense sand. So you put your foundations, and there'll be still 3 meters above the water table. And I was planning to justify my foundations for them to be shallow foundations in using sustainability. Now, sustainability, I understand that the exam has been updated, and now there is a strong emphasis in the sustainability part, especially in the section 1 and section 2 of the exam. In the section 2, there's actually some calculations required for embodied carbon that are requested, and I will be making videos of the latest exam showing how to do these calculations for sustainability, and a different video, because in this one, in the early 2023, they didn't seem to have requested yet. Now, once we have defined the ground slab requirements and the foundation requirements and your ground conditions, then normally what I do is I sketch 2 possible options. A way that I do that is I just put 2 sections or 2 elevations, and then I start considering, okay, how am I going to support this structure? How can I make it, different? Because I need 2 alternatives that are very distinct. One way to make it very distinct is support them from different places. Now, can I support it from the side? Can I support it from the bottom? Can I support it from the top? And that's what I did in here. So the one on the left side, you can be supported from the top, and the one on the right hand side, the second option, supported from the bottom. The layout, I was planning to change it by making use of the transfer structure that they allow in level 2 and level 3. And then the last thing that I changed is the material. These are the 3 main things where most people seem to fail in the exam. A common reason why people fail the exam is because of not providing 2 very distinct alternatives. So I make sure that I provide 2 different alternatives by making sure that these 3 points are completely different in the 2 options that I put. The first one is the material, the second one is the layout, and the third one is how am I supporting it, or how is the load being transferred. If you, instead of support, you can just change it to load transfer. In this case, I was planning to make the first one different by making sure there was steel, the second one concrete. Now you got 1 tick there because the material is different. Then the second one is the support or the load transfer. In the first example, I was planning to make the main truss to be at the roof, and then hangers to each side of the building supporting the cantilever below. And in the second option, instead of having hangers and with the structure at the top, then I was planning to put the structure below or at the bottom of the cantilever, and then supporting the roof by columns that are sticking out or coming out of the cantilever. And the third point, which was a layout, I wanted to make it different by the first one making sure that it was on open space and only supported by perimeter columns. And the second one, the second option, I wanted to make sure that I included a transfer structure that would make it the layout very different. So probably the internal columns I would use them for the second option, which I wouldn't select or choose for my final option. Now then you have to start developing the option 1. Again, in this case I just did it very poorly. The pens didn't help, but you have to make sure that you do it nice, tidy and neat in your exam, and you explain properly everything that you are doing. Then I'm going to be uploading resolved or responded past papers that I've done, showing the quality that is expected for the output or the results of the exam. This that I'm showing in the screen is just for the explanation purposes, but it doesn't really show the quality that is expected. Then I start with 2 schemes. I start making sure that I show the plan view and a section to show the functional frame of the structure. So I'm showing a plan view of the level 1 to level 3, which is going to be consistent throughout the height of the building. So the columns, of course, I started first at the corners, and then they tell you that you have to have 12 columns. I'm going to show them in green in here, and they need to be spaced at minimum 12 meters distance between them. I was debating whether to put it in the middle or to put it aligned with the columns that are in the service core. In the end, you'll see later, I changed them to be aligned with the service core, because if they're aligned with the service core, then they do go all the way up to the roof area. The changes in orientation, and I make sure that I have more support, a bigger number of supports for the roof, which is going to be in a different orientation. Otherwise, my spacing for the roof was much bigger. Next is to show the other plan view, which is going to be the one at level 4. And here's where I realized, right, in the current location, I have columns that are going to be internal at level 4 if they carry it through, and that's not allowed in the client's requirements. So I decided to change the alignment or the location of the columns to align with the service core. Once I align with the service core, then you can see you had 4 perimeter columns. So you show your functional frame in a plan view. It's always very useful to show sections, not only the sections to show the functional frame, but also to show the load path and the stability members. So in this section and in plan view for the roof level, I'm showing the vertical bracing. There's going to be the service cores. It's always useful to have a zoom in area when you want to explain something additional in there. In this case, I was showing that I would need vertical bracing, but because it needs to be functional, your building, then your service core needs to have an access. Once you have shown the stability, it's then definitely needed a great idea to show the load transfer or the load path from the roof onto the column to the beams, then from the beams or trusses to the columns, and then down to the foundations. You show that load path. And the proposal in this option 1 was to include a composite metal deck floor. It's a composite metal deck concrete floor for it to act as a diaphragm and transfer the lateral stability from the service core to the entire of the structure. So that type of floor provides continuity, and then diaphragm effect can be taken from it. Again, another zoom-in area where I'm trying to show how is the load going to be transferred from the roof through the trusses, showing what's going to be in tension, what's going to be in compression, and in this case in the cantilever part, because it's cantilevering, the top part, or the top core will be in tension and the bottom core will be in compression. So I'll try to show, even showing bigger arrows when you go down the building, how the load is transferred from the roof and from each floor down to the foundations, and even show in purple the vertical loads that are transferred to the top truss via the hangers. It's very messy, and as I say, it's great I think it's not good enough for explanation, but definitely not good enough for what you're planning to, or what you should be showing in the exam. And for next one, I'll make sure that I use a better pen. I'm trying to show now how the lateral stability is achieved, also showing the load transfer from the lateral loads to the vertical bracing. One thing that I used to miss a lot when I was practicing for the exam was the ground slab. In my head, it was ground bearing slab, but I forgot to add it to the exam all the time. And once you have done that for option 1, then option 2 starts. And again, you need to make it very distinct with the 3 items: material, support or load transfer, and the layout. I started to show the structural frame, showing where the columns were going to be at level 1, level 2, level 3, straight away, different to the option 1. And it's because I was planning to put those 2 additional columns that you'll see in the middle, which are the intermediate ones that are going to be a transfer, or they're going to need a transfer structure to support the roof above and to support the columns itself. You carry on doing the same process that you did for the option 1, but for option 2. The main difference for the option 1 and option 2 is that once you have your option 2, you know straight away what you're going to go for. You already went through the requirements for option 1, and then for option 2 you just need to make sure that you go through the requirements, but differently. In this case, as I said previously, the floor of the top level is going to be the structural part, the main support, and it's going to have columns that are going to be supporting the roof itself. The plan is to make it concrete, so it was going to be a 2-way span slab. Again, similar to option 1, we show the load transfer and the lateral stability, how we're trying to provide it, in this case with a concrete core. And then I tried there to zoom in the 2 main areas. First, the cantilever part, and how is that going to be transferring the loads. So previously it was a truss, and I show how the truss was transferring the loads in tension, compression, etc. And now it was just a cantilever beam in bending. Also how the concrete core, instead of being a vertical bracing that transferred the forces by tensile forces when the cross bracing gets activated, for example, in this case, is under bending, and I show kind of like a basic distribution of stresses at the bottom of the core, what it would be expected. Again, the quality of the sketches was bad. Don't really follow those. The sketches should be much better, but as I say, I'll get a better pen, and from now on the quality of my sketches will improve a lot. Also, as I mentioned before, you can actually see the actual expected quality of the sketches in the previous or past papers that I'm going to be uploading. Finally, during my practice for the exam, I always did a table comparing option 1 and option 2, providing what was the positives and the negatives for each of the options. And in this case, the option 1 had way more positives, in my opinion, than the option 3. Some of them were, for example, the option 1 was lighter, it was easier to build, probably faster construction, and because it was lighter, that also meant that it was likely more sustainable. However, option 2, the main thing, was robust. But because I didn't have enough positive or pros of the option 2, so the roof, instead of being just a flat roof, let's make it an arch, and then I show then an arch structure. Once you finish your table, you should also show a summary of what was your thought process in doing this. So you show the pros and cons, and then you create a summary. I like to start with the first option that I talk about, the one that I'm not going to choose. So I say all the pros of the one that I'm not going to choose, and say, however, these are the downsides, and the other option, in this case the option 2, these are the pros, which basically overcome those downsides. And this is the reason then why it was chosen. So I'm going to leave it here for today and just wrap up. And the next video is going to be section 1, 1b, the part of the letter. Hopefully by then I have a better pen and I can write properly, and then it won't look as messy as this one.